This video is about how to draw Lewis structures of what are called hydrocarbons. So first of all, what is a hydrocarbon? It's just a molecule that contains carbon and hydrogen, and sometimes, a lot of times, hydrocarbons also have other elements in them, commonly oxygen, nitrogen, sulfur, maybe a halogen like fluorine, chlorine, bromine, or iodine. And here's the thing, a lot of times the order of attachment is given in the formula. Not always, but the way I'm going to draw them for you, it will be. So what do I mean by that? Well, here's a hydrocarbon. It's CH3, CH2, CH2, CH3. Now I could have written this formula as C4H10, but that would not give you any information as to the order of attachment, so I write it this way. And what we know is that hydrogen can never be in the middle. It always has to be on the outside. Hydrogen only can hold 2 electrons, and so it can only form one bond. That means it has to always be on the outside. And so what this formula tells you is that you have a carbon, and on that carbon, outside of it, there are these 3 hydrogens. So there's that first carbon, the 3 hydrogens outside of it, and that this carbon is directly attached to this next carbon, that's this one right here, and that carbon has 2 hydrogens attached to it. 1, 2. These 2 hydrogens are here. And this carbon has another carbon attached to it, which is this, which also has 2 hydrogens attached to it. And then this is attached to a 4th carbon, this one right here, which has 3 hydrogens outside of it. So that, do you see how this formula here gives you the order of attachment? And so we want to draw the Lewis structure. We count up the valence electrons. There's 4 carbons times 4 valence electrons each is 16, plus there's 10 hydrogens each with 1 valence electron, and so 26 valence electrons. Next, we want to connect the atoms. So when we do that, we connect the outer atoms to the middle ones and the middle ones to each other. We use 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26 electrons. We've used up all of our electrons. Checking the octet rule, each hydrogen sees 2 electrons, and that's good. That's its octet rule. Each carbon sees 2, 4, 6, 8. So every atom there has the octet rule satisfied. We've used up all of our valence electrons. We're finished. There's our Lewis structure. Let's do another one. So there's a formula here for a hydrocarbon, and CH, CH2, CH, count up the valence electrons, should be 26 again. But now, okay, we know that this carbon here has 1 hydrogen attached to it. That's this one right here. This is directly attached to another carbon which has no hydrogens on it. That's this guy right here. Attached to another one which has 2 hydrogens. So this carbon is this one, and these 2 hydrogens are these 2. Attached to another carbon, which is this, which has 1 hydrogen. There it is. And the final carbon has 2 hydrogens on it right here. So our next step, once we have the order, is to attach the atoms to each other. So we do it like this. We use 2, 4, 6, 8, 10, 12, 14, 16, 18, 20 of our 26. So now we have 6 valence electrons left. Now in this structure, we do have some atoms whose octet rule is not satisfied yet. So we're going to try to do that with the 6 electrons. So we can't satisfy everybody. So one way of distributing those 6 electrons would be to put 2 here, and 2 here. Yeah, there's other possibilities. You could put 2 here, maybe 4 here. If you put 2 here and 2 here, though, you're going to end up running out of electrons over here. So let's try this one. So we've run out of electrons, but this carbon only sees 2, 4, 6. This one only sees 2, 4, 6 electrons. This guy is good. This sees 2, 4, 6. This sees 2, 4, 6, 8. So we have about 3 carbons that don't have the octet rule satisfied. So I'm going to make some double, maybe triple bonds. Let's see. So if we take the 1 lone pair, the 2 electrons that were here, and make a bond, and the same thing here, we get a triple bond. And what that does for us is that gives this carbon 2, 4, 6, 8 valence electrons, as does this. So that's good. The hydrogens are all good. They all see 2. This is good. And now what we did is we took these 2 electrons here, this lone pair, and made it into a double bond here. So now this carbon sees 2, 4, 6, 8. This sees 2, 4, 6, 8. And we're finished. Everybody has the octet rule satisfied, and we've used up all of our valence electrons. Let's do another one. Now, when I draw formulas, when I want you to draw a Lewis structure, if I put an atom or a group of atoms in parentheses, what that will mean is that that atom or group of atoms is attached to the atom that's directly to its left. Unless it's a hydrogen, then it's attached to the one before that. In this case, this is telling you that this oxygen here in the parentheses is outside, attached to this carbon right here. And so the order of attachment will be this carbon with 3 hydrogens, 2, 3, this carbon with an oxygen outside, and then this carbon with 3 hydrogens attached. Count up the valence electrons, we get 24. So now, attaching the atoms to each other, we use 2, 4, 6, 8, 10, 12, 14, 16, 18 of the 24. We have 6 valence electrons left. Our next step is going to be to satisfy the octet rule for the outer atoms. All the hydrogens are good, but this oxygen needs 6 more, and we have them, so we put those 6 electrons on here. We have 0 valence electrons left, but we still have a carbon who's missing 2 valence electrons, right? Because this guy only sees 2, 4, 6, and needs 8. So we're just going to look for an atom that's directly attached to this that has 1 or more lone pairs. That's going to be this oxygen here. And we're going to take 2 electrons, 1 lone pair, and we're going to make it into a bond. So there we have a double bond here. This oxygen sees 2, 4, 6, 8. This carbon sees 2, 4, 6, 8. Everybody's happy. We're done. Let's do another one. Now see, this is in contrast to what you just saw. Now this oxygen is not in parentheses, so that's going to tell you that this oxygen is directly attached to this and is also directly attached to this guy. So the order of attachment will be this carbon with 3 hydrogens outside of it, 1, 2, 3, and then this oxygen, and then this carbon with 3 hydrogens attached to it. And if you count them up, there should be 20 valence electrons. So now attaching the atoms to each other, we use up 2, 4, 6, 8, 10, 12, 14, 16. We have 4 left. So satisfying the octet rule, all the hydrogens are good. Both of the carbons are good. They each see 2, 4, 6, 8. But the oxygen only sees 4, needs 4 more. So we're going to take these guys and put them right on there as 2 lone pairs. Now everybody has the octet rule satisfied. All the electrons are used up. We're done.